Hello everyone, welcome to my another video of the digital system series, and today we're going to talk about the number base system. Alrighty, so what is number base system? So let's recall back on the previous video, which is the computer architectures and binary numbers. You know that like binary is a number that make up by like two things, which is 0 or 1, right? Binary. The example is gotta be either 0 0 0 1 1 0 and so on. Like any number, you can have like a long binary number as long as it has to be either 0 or 1 or both at the same time, right? So this is the example of a base 2 number. Okay, this is the base 2 number example. So what if we have something like a base 3 numbers? What is gonna be different? So from the base 2, it has to make up by 0 or 1. But for base 3, it has to make up by either 0 or 1 or 2. Like it has to be 3 numbers. So it can be any number as long as it has been generated by those 3. So for example, we have 1 2, which is make like either by 1 or 2, right? Belong to here. That is valid. 1 0, yeah, it's still base 3 number. 22, that's totally fine. 21, that's fine. 1 1, that's perfectly fine. Or 1 2 0, that's fine because it's make it by 0 or 1 or 2 or all of them or any of them, just any combination of those 3. So those are base 3 numbers. Alright, so you guys kind of get a hang of that. Let me give you guys another example just to make sure. So let's say base 4 number. So which means this number has to be make up by 0, 1, 2, and 3. Now you have the 3. The example gonna be let's say 1 2 3 0, that's fine. 3 2 1, that's totally fine. 1 0 0, this is fine. I mean, this look like binary, but it's also base 4 as well because it have like 0 1 in here. So this also counts like base 4 according to this, right? So we can have this 2 0 0. So this is the example of base 4, like any number that can be generated or created by those 4 numbers or those 4 like elements. All right. So now let me introduce to you guys one of the popular base number that we use in our life actually, which is the base 10 number. So base 10 number is any number that can be created by the following. It's gonna be 0 1 2 3 4 5 6 7 8 9. So any number that can be generated by those elements right here are going to be considered at the base 10 number. And it's actually the system that we use in our life, in our, we human, right? How many finger we have? We have like 10 finger, right? 1 2 3, we have 10 finger, right? But like even though 10 finger, you can have number 10, right? But this number 10 is actually the combination of like what? 1 and 0, right? Or let's say 12, it's gonna be combination of like 1 and 2. And those 1 0 1 2 right here, those number right here, it still belong to this list right here, right? Like you can generate any number as long as like belong to this list. Therefore the counting system, the counting system that we use in our life since we was like born or since we learn math in high school or primary school or anywhere, they are all belong to the base 10 number. Okay, so, and instead of like, you know, saying like base 10 number, it's kind of long, right? So that's why we have a name for base 10 number, which is a decimal. Okay, so base 10 mean decimal. It's just like binary, right? You guys remember? So we have like base 2 number. Another way to say base 2 number is actually a binary, right? Yeah, so they have their own name. Like base 2 is binary and base 10 is decimal, right? They basically the same. Okay, so now let's compare and contrast between binary and decimal. Okay, let's see the difference between those two. Okay, so let's say in binary 0, so decimal always have 0. Okay, and after 0 in binary you can have like number 1, and for decimal you can still have number 1. It's keep increasing. However, like from binary, the next number after 1 is gonna be 1 0, but for decimal we can have up to 2, right? So you can guess, like you can have 1 1, and in here you have 3. In here you can have a 1 0 0. You can have 4, 1 0 1. You can have 5, and 1 1 0. You have 6, 1 1 1. You can have 7, and yeah, so on. So from this list you can see like each binary is like it's mapped to a certain decimal, right? Each binary mapped to a certain decimal. Like 1 0 0 gonna be number 4 in decimal. 1 0 1 can be number 5 in decimal. All right, or maybe 1 1 1 gonna be number 7 in decimal. So I mean, like you guys can have like this type like table right here, you know, to trace down right away. But let's say I give you guys some random binary. Okay, let's say I give you 1 0 1 0. Okay, let's say I give you guys this binary right here, and then I ask you guys like, what is the decimal of this? Right, this is binary, and then I ask you guys like, what is the decimal of this guy right here? Right, I mean, you guys can, you know, continue this table to find a decimal, but that's very long, right? So what is the fast way to convert like this, to convert to decimal? What is the fast way? So the trick is gonna be like this. I will show you guys. So when you create this, so for 1 0 1 0, we always do the trick like this. This bit right here, this is called a list significant bit. Right, you can see the LSB, and this top right here is the most significant bit, or the MSB. Okay, so the least significant bit is represent for 2 power 0, and 2 represent for the base 2, which is binary. And this one right here is gonna be 2 power 1. This one right here gonna be 2 power 2. This one right here gonna be 2 power 3. Okay, so from here you're gonna do something like this. So 2 power 3, you're gonna times 1. You're gonna have 2 power 3 times 1, and 2 power 2, you're gonna times 0, and then 2 power 1, you're gonna times 1, and lastly in here you're gonna have 0. So now you add all this together. Okay, so 2 power 3 is gonna be 8, right? And 0 is like 2. 2 power 1 times 1 is 2, right? And 2 plus 0 again. Therefore your answer is gonna be 10. And this is your decimal answer. Decimal. Okay, so this is the formula for you to convert the binary to decimal. Let's have another example to help you guys, have a better understanding of this. Okay, so let's say I want to convert a number that is 11011. Okay, now I want to convert it to decimal. So how I'm gonna do that? So from here, right, the least significant bit right here is always 2 power 0. Okay, and this one right here gonna be 2 power 1, this one 2 power 2, this one is 2 power 3, this one is 2 power 4. Okay, so now you're gonna have 2 power 4 times 1, right? 2 power 4 times 1, and here you have 2 power 3 times 1, and here you're gonna have 2 power 2 times 0, which is 0. 2 power 1 times 1, you're gonna have 2 power 1 times 1, and lastly 2 power 0 times 1, 2 power 0 times 1. So from this, right, this thing right here, you're gonna have 16. This thing right here, you're gonna have 8. You have 0. This one you're gonna be 2, and lastly right here you're gonna be 1. So when you add all these numbers together, what you're gonna have? You're gonna have 27, and this is your decimal version of this number. So the answer right here is gonna be 27. Okay, so I just show you guys how to convert from binary into decimal, but what about I do it in another way around, like from decimal into binary, like from 1 I convert back to 1. So let's say I have like 3 in decimal, and you guys have to like convert 3 into 1. I give you guys like 5, and you guys has to give me 101. So how you gonna do that? So I'm gonna show you guys a trick in order to do this like conversion step from decimal back to binary. Okay, so let's have some example. Let's say I have a decimal, which is let's say number 8. Okay, and then I want to convert it to binary. Okay, so how I'm gonna do it? So the first steps, we're gonna have like 8 divided by 2. We always divide by 2. So what you're gonna have? You have 4, right? And 4 times 2 is 8. So that's why the remainder is 0. The remainder, so this is called remainder. Remainder. So remainder in Vietnamese is số dư, right? So you guys know số dư, right? When you divide some number, you're gonna have remainder, which is số dư. Okay, so with this, and this remainder right here is your binary bit. So 0, so you have 0 now, right? I'm gonna copy down the 0. I'm gonna have 0. Let me put it here, 0. So this is 0. Okay, now we have number 4, right? We're gonna have number 4, and then we keep divided by 2. So 4 divided by 2, what you're gonna have? You're gonna have 2, right? And 2 times 2 is 4. So the remainder right here is what? Is 0, right? So our remainder is 0. So we're gonna have 0 right here. Now you guys can see how it works, right? Now let's continue. So number 2, you're gonna divide it by 2 again. And now what you have? You have 1, right? And then 1 times 2 is 2. So that's why 2 subtract 2, you're gonna have remainder of 0 again. So you're gonna copy 0 again. Okay, now from number 1, you're gonna do division again. You're gonna divide it by 2. Okay, so now see what happened. So 1 and 2, what you gonna have? So 1, can you divide by 2? No. So you're gonna have 0. 0 times 2 is 0, and 1 subtract by 0. So what is your remainder? It's actually 1, right? And this is your 1. This is your new bit. So here's one thing that you guys should pay attention about this procedure, this step right here. Like this whole thing is stop until you have 0 right here. Stop until 0, right? You stop right here, right? You see 0 right here, then you stop doing division. Stop division. So I'm gonna write here, stop division. Okay, so you stop division until you see the 0. So your final answer is gonna be 1000. And also, if you guys like look carefully, this is actually your binary numbers, right? The remainder. Everything here is remainder, right? They are remainder. They are remainder, right? And the remainder give you the binary numbers like 1000. Okay, let's have another example for you guys to reinforcing this knowledge. Okay, so let's try 24. Okay, so decimal of 24. What is the binary? All right, so I'm gonna do 24. I'm gonna divide it by 2. So you're gonna have 12, and your remainder is gonna be 0. All right. So this is your new binary bit. So gonna have 0. Okay. So now 12, you're gonna divide it by 2. And what you're gonna have? You have 6, right? 6 times 2 is 12. So your remainder gonna be 0 again. So you have 0 here. Okay, it's now 6 divided by 2. What you're gonna have? You have 3, right? It's 3. And from here, your remainder is 0 again. So I'm gonna have 0. And from 3, let's continue because it's 3, right? It's not 0, so you don't stop it yet, right? So 3 divided by 2, you're gonna have 1, right? And now you're gonna have the remainder of 1, right? So this is your like new bit. So I put 1 right here. So of 1, you're gonna divide it by 2 again. So 1 divided by 2, so you have to be 0 right here, right? And now your remainder is gonna be 1 because 0 times 2 is 0, right? So 1 subtract 0 give you 1. And because it is like a 0 right now, right? So what does it mean? You have to stop. So I put stop. Okay, so this is also your new bit. So I put it down 1. So let's double check again. So you're gonna circle. I'm gonna circle like this remainders, right? You see your binary gonna be 1 1 0 0 0, and you see 1 1 0 0 0. So this is the binary of 24. Let's say we have 33. Yeah, okay. So what is the binary of 33? Okay, so you're gonna have a 33 divided by 2. I'm gonna have like 16, right? And so what is my remainder? It's gonna be 1, right? So your new binary bit is gonna be 1. So I have 1. Okay, so from 16, I'm gonna divide it by 2 again. So I'm gonna have 8, right? And 8 times 2 is 16. So this one have 0 remainder. So I have 0 right here. So 8 divided by 2, gonna have 4, and this one have 0 remainder. 0, 4 divided by 2, and I have like 2 right here. 0 remainder again. Gonna put it right here. And from 2, I divided by 2, so I have like 1, and 0 remainder again. So 0. And lastly, 1 divided by 2, which is 0. Now we stop, and the remainder is gonna be 1. So 1. Therefore, our answers for 33 is gonna be 100001. This is our final solution. Okay.